You're in the field, it's silent. Then bzzzzz, you flinch. Was it a bug? Maybe, but maybe not. What if it was a spy? What if your enemy could see you, hear you, track your every move using something so small? It could land on your shoulder, and you'd never know. This is the next frontier of espionage. Engineered by China's National University of Defense Technology, this prototype drone is just 13 millimeters long, smaller than a coin, lighter than a paperclip, and silent enough to disappear into the hum of a battlefield. In this video, we'll dissect this micro drone piece by piece, what it's made of, how it flies, how it spies, and why it's already rewriting the rules of modern warfare. Inside China's mosquito drone, the world's smallest spy, the why behind the insect drone. Modern drones are powerful, but obvious. They buzz, they glow. They're big enough to see, hear, and shoot down. China saw a gap, a surveillance blind spot. The kind of mission where stealth isn't optional, it's essential. So, instead of building bigger and better, they built smaller and smarter. Imagine this, a drone that can slip unnoticed through a cracked window, perch on a ceiling light, and record conversations without a whisper. The target never knows. It's there. No wings flapping, no camera lens glaring, just silent surveillance in a tiny shell. Design insect engineering meets military hardware. At the core of this marvel is a titanium aluminum alloy fuselage, an ultralight. The whole body weighs less than half a gram. Its shape, rod-like, built for minimal air resistance and stability. Its wings, they're straight out of nature, inspired by insect vein patterns. They flutter 120 times per second using piezoelectric actuators, ultra-thin materials that flex when electrically stimulated. That vibration creates tiny swirling vortices of air, just enough lift to keep the drone airborne, but not enough to make a sound you'd hear. And the matte black coating, it scatters infrared light, allowing it to disappear in thermal imaging. So while your night vision goggles see nothing unusual, this drone is already watching you. Tiny tech brains in a match head. Now here's where it gets wild. The onboard processor is a 9-bit RISC chip etched using MEMS technology. That's microelectromechanical systems. It's not just small, it's microscopic. The processor doesn't analyze anything. It simply follows instructions stored in just 12 kilobytes of memory. It moves, balances, and returns raw data. All intelligence lives at the ground station. This keeps the drone featherlight and energy. Up front is a 300 by 300 CMOS sensor, a pixel count laughable by modern standards. But when you're only spotting shapes, faces, or firearms, it's enough. A wide fisheye lens offers a 160 view, and in low light, a shortwave infrared LED kicks in, creating a grainy but readable black and white image even in near total darkness. Listening in the drone that hears you. Type surveillance isn't just about sight, it's about sound, so they fitted a MEMS microphone. Sensitive across 20 Hz to 12 kHz, it can pick up voices and even keyboard clicks from 2 meters away. And here's the trick. They don't try to cancel the wing noise on board. They let the ground station clean up the signal. That saves space, power, and weight. Compressed audio is streamed back at just 8 kbps, barely more than dial-up internet. But again, it's enough. Because in spy tech, just enough is everything. Perching mode, the secret to stealth. When the drone lands, it vanishes literally. Its 3 carbon fiber legs detect contact and immediately shut down the wings. No movement, no sound, just a black speck on a wall. This perching mode isn't just stealthy, it's strategic. It slashes battery usage by 2/3. A 20 mAh lithium polymer cell wrapped in graphene powers it all. In flight, you get 7 minutes of movement, but perched, you can listen for nearly 2 hours. And charging, a magnetic inductive port fills it in under 6 minutes. No wires, no access panels, no breakpoint. Everything about this drone screams don't touch, just use. It's optimized for one thing: gather intel, then disappear. Backup systems and failsafes to avoid detection. It keeps flight short and precise. A 2.4 GHz transmitter to handles primary communication, backed by L-band radio. Max range 50 meters outside, 20 meters indoors. If connection drops, the drone doesn't crash, it lands quietly wherever it can stick. That means no bang, no broken parts, and no evidence. Its sensors include a 3-axis gyroscope, a barometric pressure reader accurate to 10 centimeters, and some basic onboard vision to help with positioning. There's no GPS because GPS modules are too bulky. So how does it know where it is? The answer: computer vision and ground station data. It flies by seeing, not by satellite. Undetectable? Not quite. So, is it completely invisible? Almost, but not quite. Some labs are working on AI that can detect the sound of piezoelectric wings. Others are training computer vision to spot insect flight patterns that don't match real bugs. But even then, how do you act fast enough? A millimeter-sized drone moves quickly and disappears even faster. One flap, one perch, and it's gone. You won't hear it, you won't see it, you won't stop it. Even advanced anti-drone lasers don't calibrate below 1 gram. And radar gets nothing but static. Civilian uses in dark potential. Here's the other twist. This isn't just for the military. In agriculture, it can slip under thick plant canopies, counting pests in real time. In medicine, a sterile version could navigate blood vessels. In disaster zones, it might crawl into collapsed buildings, listening for heartbeats. But what happens when this tech is in the hands of spies, criminals, or worse, corporate surveillance? There are no nano-drone laws, no international treaties, nothing. And in countries where privacy is already fragile, this could be the perfect tool for oppression. Production, it's closer than you think so far. Only lab prototypes exist, but the roadmap is clear. Mass production through automated microscale assembly. Materials currently cost around $250 per unit in bulk. That could drop below $90. Give every recon team 20 of these and suddenly, every room, rooftop, or alley becomes a live surveillance feed. But here's the problem. Human brains can't process that much data in real time. So the next step, smarter field AI systems that can prioritize, filter, and flag what matters before the data overload becomes a liability. China's mosquito drone isn't just a breakthrough, it's a warning. A warning that the surveillance arms race isn't about building bigger, it's about going invisible. If you blink, you'll miss it. If you don't listen, it's already heard you. And if you don't regulate it, it'll be watching. What's next? In our next episode, we'll be dissecting Norway's Black Hornet and Harvard's Robo, two of the world's most advanced micro-drones. If you care about the future of privacy, warfare, and surveillance, subscribe now. This battlefield, it is getting smaller, and it's already here. Drop a comment below. Would you rather be watched or left in the dark? See you in the next video.